How can biology be programmable? Programmable stuff, when we think of it, is like code. You write in Python, you write in Java, you write in TypeScript. There's all these different programming languages. It's literally a language for programming that allows you to code something. Biology is a little bit different, though. Biology all has to do with DNA, and how is DNA programmable? And if it was programmable, what are the market opportunities that exist, the life opportunities that exist to solve massive problems in the world? If what you could do with coding on computers and build hundreds of millions of applications that we've done over the past 20 years, you could do with actual biological DNA. That is the question that Ginkgo Bioworks is a company that is trying to answer. And what we're going to react to right now is a clip from Jason Kelly on a podcast, their CEO, basically explaining how DNA is programmable and what does that mean for biology writ large, and what does that mean for different applications that can be built. So let's react to it and then we'll talk about it.
So you keep on going and bringing up the word like program. How is like biology programmable, and also with that, like how does that coincide with the mission for Ginkgo Bioworks as a future? You kind of gave it, but can you give a little bit more perspective into that?
Sure. Yeah. So here's what's magical about biology, right? So if you think about what life does, it's basically like giving birth to an offspring, and it wants to communicate the genes, like some information from the parent to the offspring. And biology freaking figured out the exact same thing that we figured out mid last century, with the advent of computers, which is if you want to communicate information with high fidelity, the best way to do it is digitally. Remember, there's like records and stuff, that's like analog, like waves and all that crap. But if you really want to get it exactly the same, use a CD, right? And that digital information transfer is also really good to pass information to your offspring, and it's freaking what biology invented for DNA. Same. What's that?
Scalable.
It's scalable, and it's.
This is a really interesting analogy, right? Half a decade ago, or half a century ago, we figured out that if we want to control the world's information or allow information to be understandable and scalable, then we need to have something that communicates with something else, which are like, bits and pieces, zeros and ones on a computer that are able to allow you to create this code, which allows the information of the world to be stored within it and then, manufactured on top of. You have all these different applications that can use the way information is stored to be able to build the Reddit, the Googles, the YouTubes, the Instagrams of the world. That is a unbelievably interesting process that has unlocked trillions of dollars opportunity in the information age, because you have something that communicates to something else in the context of computers. Biology has been doing this since forever. When someone is giving birth, when you have a baby in your womb for 9 months, there's a lot of like autonomous communication of information in order for that life to become a life. And what Jason Kelly's talking about is if that's already happening in biology, and we could take that and program it, and make it a pseudo computer, right, via technology, because the biology is already doing it. If we could just add the technology element to it, what could that enable, and how many applications could be built on top of that?
It's high content fidelity, right? Like it passes the information well. And so along we come here, human beings, again, late 1970s, and we're like, holy crap, it's digital code. Like, why don't we edit it? Right? Because digital code natively is easy to work with. And so that's really why we say it's programmable. It's because, like, by some miracle, right around the time we're figuring out the structure of DNA, we're also inventing the first programmable human technology, computers. And we're like, oh my God, right? It's the same thing. Yeah. And so we like that language, right? Now, we're also like, the founders are all like MIT nerds who are like computer scientists and kind of came into this as a bunch of, computer and engineering folks. And so it made sense to us.
Yeah.
Right? When we saw biology, we saw code.
Yeah.
That's a little different than like how the biologists see it a little bit at the time.
That's a deep vision.
It's cool. Yeah. It's really exciting. Like, and I think it's something that, like, as a society, we need to like build comfort with and think about, right? Because it is a big deal.
It's a new concept, yeah.
Yeah, and biology does a lot of important stuff for us, by the way. Like produce the atmosphere, make all our food. Like, we're made out of biology, right? Like, so as we enter like this era of being able to design biology, like it's a collective topic. Right? Like, we all need to decide like what the right thing is to do with it, and companies like Ginkgo need to build trust with the public. Like, I think it's amazing what you all are doing, talking to people out, just general public about investing in companies. Like, people need to understand us
Yes.
So that we can build trust with them because we're deploying powerful technology. That's important to me, right? And so it's like one of the reasons I think what you all are doing is great.
So this is an interesting thing, right? If you can program DNA, because at the end of the day, all of it is human digital code, which is the whole thing that this is the whole premise of programmable genomic sequencing, then there is the ability to now build and build a lot of different things. And so some of the examples that DNA has been able to work with are things like cannabis. If you can program or sequence a digital piece of DNA, instead of having to grow all this type of cannabis, you could synthetically create it with synthetic biology. Animal meats, the Impossible Burger. DNA was not involved in literally creating the Impossible Burger, but things like that could be built on top of them. Antibiotics and the ability, we mass produce Tylenol and aspirin, and all of this is just biology that we've been able to figure out what works in terms of formulas. How could we do that for other types of diseases that exist? And for different types of problems that also exist. Biology, and what Jason Kelly is talking about at the end is, and this is where I like the vision of the founder, in particular of him as the CEO. He thinks of biology in a way that makes biology cool. And all of us thought biology was cool at one point. We all went to, 5th grade and we watched these biology videos and we all thought, oh my God, it's so cool. The mitochondria, the powerhouse of the cell, the ribosomes. You remember this stuff. It's like, but it fades away because we're humans and we take it all for granted that our brain just works the way it works and, our body just functions the way it functions, and then we move on and we go on with our lives. Jason Kelly's love for biology, and he got a PhD in biology at MIT, that never went away. And the reason it never went away is because he thought there was a opportunity to use biology and the fact that it could communicate with itself, just like humans figured out with computers in the 1970s, to be mixed with technology and actually build applications that allowed that biology to now matter. And this is the whole concept of programmable DNA. Biology is the atmosphere. Biology is life. Biology is plants. Biology is how we have food. All of our food. I mean, just think of everything that's genetically modified when it comes to food. There are hundreds of millions of use cases when it comes to biology. And the world is only getting more and more complex. Literally, COVID happened. We needed a vaccine. We figured it out in 6 months. Great job to human beings. There's going to be more and more things that happen that don't have to be entire pandemics, but could be different use cases to solve problems. Food shortages. How can programmable DNA play a role in that? Diseases. How can programmable DNA play a role in that? Climate change. How can there's just applications upon applications. And just like for the internet, where there were hundreds of millions of ideas people had, you have the winners like the Reddit, the YouTube, and the TikTok. And if you could have invested in the internet, which I guess the earliest way is invest in Microsoft because they have the browser, invest in Apple because they have the App Store, then you made a lot of money. If you could invest in the platform that's allowing those cell-based programming applications to be built on top of it, it might take a while, but there might be a big market opportunity there. So those are my thoughts on why biology is incredibly important. Let me know what you guys think as well and how you feel about biology at the intersection of technology. Thanks so much for listening and watching. I'll see you in the next one.